Okay, dann bin ich jetzt vielleicht live. Ich gucke mal hier im Stream. Ja, da wird irgendwas geschrieben im Chat. So, da wurde gerade gefragt, ob wir Deutsch oder Englisch machen. So, mir ist das eigentlich egal. So, for me, it both would be fine, German or English. I don't care, to be honest. I don't know, like the audience can decide, or we do it in German, whatever. Ich glaube, es war Deutsch geplant, ja. So, genau. Jetzt muss ich dazu sagen, das ist das erste Mal, dass ich in so einem Stream-Format das hier mache. Deswegen verzeiht mir das bitte, wenn das irgendwie ein bisschen strange wird oder vom Ablauf her ein bisschen noch nicht perfekt. Ich versuche hier mein Bestes. Und ich versuche auch vor allen Dingen, dass... ach, man hört mich ja gar nicht, ne? So, yes. Ich war schon gemutet die ganze Zeit, oder? Na, immerhin hatte ich hier Muten angeklickt. Egal. So. Entweder ich war gemutet oder nicht, aber jetzt bin ich wahrscheinlich nicht mehr gemutet. Ich wiederhole es nochmal, falls es hier irgendwie Probleme gibt beim Stream oder so, bitte ich darum, das zu verzeihen. Das ist das erste Mal, dass ich das jetzt hier in so einem Streaming-Format mache. Ich freue mich aber trotzdem, da jetzt hier virtuell bei der JUGH zu sein, JUGH Hessen. Und ich werde, now they're saying English is fine. Yeah, why not? Let's do it in English. So, yeah, it's the first time for me now doing this streaming, and let's just get started. I will talk today about integration testing with Docker and with Testcontainers, and we start first with a slide, little bit introduction about myself. So my name is Wittek, and so jetzt ist Halt. Vorher war Doppel. Okay, dann mache ich das Ding mal aus hier. Okay. Okay. I think I know what I did here. It's with the OBS, and you can have an audio input source, but you can also have the audio mixer, and I had both selected, and that was maybe the mixer. So I hope now it's better. Yeah, my name is Wittek. I'm a doctoral researcher at the Institute for Internet Security in Gelsenkirchen in Germany, at the Westphalian University of Applied Sciences, so where I'm doing my PhD. But I'm also the head of the blockchain research lab, and I'm also doing a PhD about blockchain. Not too much in this whole domain of cryptocurrencies, things like Bitcoin or so. That's not my main domain. I'm more interested in those distributed system aspects, but also in those whole smart contract stuff. There are some cool computer science things in there, and there are also some nice implementation of the Ethereum virtual machine, for example, using Java. So also nice stuff for Java developers, I think, or Java fans. In addition, I'm also kind of free consultant, doing things like workshops and coaching with my own company. And I'm one of the maintainers of the Testcontainers library. In general, a big fan about open source. And yeah, Oracle Groundbreaker Ambassador I became some time ago, and yeah, Git Kraken also. And we have a local software craftsmanship meetup in the Ruhrgebiet. I'm one of the co-organizers there as well. Yeah, I tried to be a little bit on topic and give some motivation or inspiration about why testing is cool and why we should do testing. And so I wanted to be on topic and up to date. And yesterday we had the plan to SpaceX wanted to launch the first Dragon Crew mission with crew members on board. And I think many of you also were excitedly watching. But yeah, sometimes things are outside of your control, and you can have good engineering and good testing, but the circumstances lead to you not being able to perform or execute what you have planned. So this is not something that should motivate you to test or not to test, but another story from German or European aerospace engineering history is an interesting one, and that is the Ariane 5. So this is the launch of the Ariane 5.
Décollage.
Yeah, and maybe some of you know the history about the Ariane 5, like as a very famous example of a project that was not successful, maybe, and because of a software bug, actually. So yeah, it's exploded during this launch. And there is this report that's actually online by the European Commission, I think, or by the ESA, and where they investigated how it came to this explosion, to this malfunction. And this was a data conversion error where they converted a 16-bit floating point into a 16-bit signed integer. And I think it was even at some code path that was not really necessary or whatever from a former version, from former hardware. And then at one point something like flipped, the value flipped, or like this, the signed integer flipped, and then the calculation of the orientation was totally off, and yeah. And then they made a couple of recommendations in this inquiry report about how to avoid such problems and malfunctions, and there is some interesting stuff here, like having better specifications and test requirements, but also having better test coverage. And this one I like is, as they say, test coverage of existing equipment and like those kind of things. For me, it sounds like, okay, we need also more integration tests, maybe. So I can take this as a motivation for us to talk here about integration tests today. And there is another funny story from myself and how I ended up on a dairy farm, actually, to like, yes, on the dairy farm. I was on a dairy farm to patch a JUGH application server there because of a missing integration test. And it was a couple of years ago, no, actually not that long ago, and we were developing this dairy farm management software that was also controlling the logic for the milking robots. And modern milking robots, they are at the same time milking and feeding the cows. Pretty autonomous working, and there is some complex business logic involved that determines how much milk gets pumped out of the cow, basically, and also how much food and what kind of food the cow gets. And we had it installed at a couple of test farms, and then one day we get a call from a farmer, and he said, oh, like after the last software update, suddenly like my food is empty all the time, my food storage, what's happening there? And then we checked, and yeah, every time the cow went into the box, the cow went into the box, it got the maximum food supply, and this was not like how it's supposed to be. And there was we actually had a lot of tests, a lot of unit tests that were checking this kind of business logic. So it would determine, okay, if the cow was there 1 hour ago, then now it gets less food. If it was there like last day, then it gets a higher amount of food, maybe the maximum amount of food. So I think every time it got like 2 kilogram or 5 kilogram, like pretty much, and so a lot. And we were actually lucky there, because when we looked into the logs, the calculation said actually it wants to give 30 kilogram or something to the cow, and we just were lucky that we had this maximum threshold built in. And then we found out, okay, it was a bug in one of the SQL queries. A lot of the business logic was coming from SQL queries, also for performance reasons, and it was kind of off by one error. So we didn't look at the last visit, but the visit before, and then it was always thinking, oh, it hadn't been here for a long time, let's give it maximum food. And yeah, patching this, there was no over-the-air patching, the servers not connected to the internet or anything, so you had to drive out, go into the farm, into the where the cows are standing, basically. There is a, you can say there is a small data center, but it's actually just a shack inside this like cow, how you call it, cow shack or whatever, and it smells accordingly, and then you have to go in there through the cow shit and update the server. And yeah, that was a nice story, and this is something better integration tests could have prevented this from happening. So, yes, my mission statement I try to communicate is that it's nowadays possible, and that we should strive for, that an onboarding experience for new developers or new team members can or should look like this. So a member should be able to just clone the repository and run the build, and that's all that should be necessary as a preparation to become productive. So we want a very easy setup of the complete development and test environment, and in an ideal way already defined as part of our code. And if we also have this as a given, this would mean that there is a lot less effort necessary to write integration tests and execute integration tests, which might allow us to write more and better integration tests wherever we need them and where they are necessary. And at the same time, we want to avoid integrated tests. An integrated test is a very nice term or definition I like to define later. What is an integrated test? So here we have the classic software pyramid, many might know from literature, blog posts, whatever. And many of us take it as a given that we should strive for such a shape of our test suite. And this would say we have mostly unit tests, we have some less integration tests, this middle layer, then we have some end-to-end tests, and then still from a manual tester some session-based explorative testing. And the middle is the integration test, but already here we have to talk and define what is an integration test, because the definition of integration test might be different between teams or developers or whatever. And if we talk today about integration tests, or I talk about it, then I mean all those tests that interact with external systems and external dependencies. So things like launching the application server or something like a Spring Boot context. I would consider this an integration test. Some other developers would say, okay, Spring Boot test, it's also just a unit test if it runs in one process. But for me, it feels a little bit more like an integration test, to be honest. And but of course, and most people would agree on this, all those tests that interact with external ports, with external processes, basically outside of my Java processes, so things like network or things running over the network, the file system, or very perfect example, things like a database testing interaction with this very surely is an integration test by most definitions, I would say. And yeah, we have this classical pyramid-like shape, and many would take it just as a given. But we can also maybe challenge this assumption that an ideal test suite has to have this shape, and then we can come up with new shapes that we might say are better or whatever, or different or better for our needs, suit our needs better. And we have this testing honeycomb. So yeah, honeycomb Honigwaben. And this is from a blog post from Spotify, and they say their test suite is shaped like this for their microservices, basically. And implementation detail at the bottom here means all those small unit tests, and then we have mostly integration tests. So they prefer integration tests. And then there are some integrated tests, which I will define in a second. And they say they prefer this big amount of integration tests, especially as compared to tests that would involve a lot of mocking and stubbing, because it gives them a higher confidence in the correctness of their code and application, and also it allows for potentially easier refactoring or more extremer refactoring that wouldn't have any influences on the test code itself, making the test code maybe a bit more black boxy in a certain way. And also they say their microservices have a relatively high integration surface, so to say, as compared to the amount of business logic that might be inside. So they are mostly interfacing with other microservices, maybe the outside world. So therefore it makes sense to have, in this case, maybe more integration tests than unit tests. And as compared to a monolith, a big monolith maybe, where the shape would be different potentially. So integrated test, I said, this is a term that's very nice to know and to define. And here I have the definition from J.B. Reinsberger from his blog post where he first mentioned integrated test. And J.B. Reinsberger is a guy who is like a little bit more famous in the TDD and Agile community maybe, as an author and coach, and he says, I use the term integrated test to mean any test whose result, pass or fail, depends on the correctness of the implementation of more than one piece of non-trivial behavior, which references Spotify in their blog post, and they phrase it like a test that will pass or fail based on the correctness of another system. So this is a cool definition, I think. And those tests, we want to avoid them. Like, we consider them more or less an anti-pattern, but there might be some necessary. And here are some examples for integrated test. One classic example, when we have to manually spin up other services and install and configure them in our local environment. So every time our integration test expect Postgres running locally that has been set up before by the developer, following some wiki instructions and configuring everything, then we have an integrated test, because now our test would fail if the developer misconfigured the Postgres or forgot to start it or install it or whatever. And then we don't know, did the developer make a mistake when setting up the environment, or did we broke our code, we changed our code or our application in such a way that the test should fail. Another very nice example, when we are using somehow some shared service instances. So best example is a big shared database in a test environment that all developers or maybe even all development teams share and even have to share, maybe because it's on a mainframe system or something like this. And in this case, potentially tests executed by another team or another developer could influence my tests for the better or for the worse. But whatever, we don't want to have this, because then we lose confidence in our own test execution. And also, looking at it from the other side, if changes to our system and our application would break the tests of another team, is at the same time an integrated test, just in the other direction. And this is something that would happen also if we always test in a big shared integration test environment or whatever, where everything gets deployed all the time, then the tests get executed there. And then here again, like we would say, our tests fail, but it's Friday afternoon and the stupid other team will always deploy their servers and break their APIs in the afternoon of Friday, so we don't care about the failing test. And this just is very detrimental to our confidence in our test suite. So we want to avoid this kind of things at all costs. But maybe a certain amount of integrated test is still necessary, like the last final integrated test environment. We want to have it, we want to test all those services as a whole. So that's why also in the Spotify Honeycomb there are still some integrated tests left. So yes, we want to write integration tests and good integration tests, and avoid integrated tests as much as possible. And which tools do we use? We are in the Java user group here, so of course we look in the JVM world, but actually those JVM tools we are looking at now are also usable for non-JVM languages, basically. Yeah. And the good thing is that we don't have to look that far or use any exotic stuff. We can mostly use technologies we are already using. So this means basically all our usual Java testing libraries, JUnit or whatever, but we can also use something like Spock, which I like very much, another Java testing library in Groovy, or we write the test in Groovy. But then the additional component that makes these new patterns of better integration tests possible are actually container technologies, and we are using here Docker, and then we're using Docker together with the Testcontainers library to have a better way to interact with Docker from within our usual Java environment. So normally, or actually when I gave the talk, like the first time a couple of years ago, like the first version of this kind of talk talking about Docker and testing, I tended to explain what is Docker this is nowadays normally not necessary anymore, so therefore I'm skipping this, and just the main thing why Docker makes it now possible to unlock this new integration testing patterns instead of what we had before is just the fact that starting those containers for our integration test is so lightweight and so fast as compared to the classic virtual machines we had. So those patterns we are looking at today with these infrastructure as code approaches, of course we could always do them also with virtual machines, but they were just like a little bit too slow. Like it wasn't a good flow for developers, at least in their normal development workflow, to use those virtual machines infrastructure as code approaches, I would say. And with containers, since they don't have this heavyweight guest operating system, and they just all have the shared kernel, you just have this user space instance, basically just a user space file system that gets initiated and a single process. It's so fast that all those things become feasible, and also we have very good APIs to programmatically interact with those containers. Docker has a great REST API, and by using test containers we are having an even more powerful abstraction on top of this Docker REST API. Yeah, so we are combining now our classic Java testing tools with containers, with Docker containers actually, to make the setup of our development and test environment easier, and have it described in our code, actually inside our test itself, following kind of an infrastructure as code approach in this regard. And another thing is we want to have uniformity between our build and test environments. So if we think about certain CI services and CI tools, something like GitLab CI or Travis CI, for a long time they provided a feature where you could specify in a pipeline or in a build job that you want to have a certain set of services launched by the CI system. Like you would say, okay, in my test step I want to have a MySQL or Postgres launch, and then they would launch for you a container you can interact with. And in theory it's of course a cool feature, but in practice what is not so nice about this is that you normally can't reproduce exactly this pipeline on your local development environment, and this is not the local development workflow you're having. So now you have two different environments, and therefore I argue and I advocate that it's much better to use something like test containers, so that this test environment gets initiated and created and instrumented the same way in all environments, locally and on CI. Yeah, and then also like having a good onboarding and developer experience means ideally not a lot of installation and setup of external software necessary, except for Docker in this case. And this is good and important for projects in a business, in an enterprise, but also and especially I think for open source projects. If a contributor can come, just clone a project and make a small change he sees maybe and he knows how to fix, and then he can just execute the tests, maybe even locally, and really fix the stuff without having to install any things and big dependencies, then it's really, really great for the productivity and for the onboarding experience of such new developers, also in open source project. I think especially in open source project. So yes, how we combine those two things now. We are using test containers, of course. So I'm just checking. So I'm wondering, is anyone still here or no one in the chat anymore? Because I just checked the member type, or can I see somewhere who's in the stream? Okay, if maybe someone has a number, how many viewers are in the stream, they can put it somewhere in the chat, whatever. We are looking at test containers today, mostly. So what is test containers? It's the best way to bridge this gap between Java and Docker, I would say, or one of the best approaches. And here we just see how it looks. 27. Oh, 27 is cool. I like this. This is basically the vanilla API, so to say, how you can use test containers without any test framework integration or whatever. So you basically have an object-oriented abstraction over Docker containers, which is very useful and convenient for us as Java developers that like often object-oriented abstractions. So here in this case, we just initiate any container with any image we want, like just what we would do with the Docker command line. So in this case, it will become a container with a certain Redis version. We also specify that we want to interact with a certain port, and then we run start, and then we can do things, and then we can say stop, and then the container will be gone automatically and also deleted and cleaned up. Yeah, and I think this is is already pretty easy. And one important thing maybe is that this call to start is a blocking synchronous call that will wait for the application in the container to be ready, to be started. This is something different than having the container started, and we can look at maybe the difference and what this difference might mean here on the command line. Okay, so now a bit bigger maybe. So when I run a Postgres database like this, I create a new container, Docker container, that like should be a Postgres. We see the container get created like in sub-seconds, kind of nearly instantaneous. So if we would just wait in the start call until the container is created, it would directly move on. But what is actually happening when we do this run? So I had this. Yeah, so let's run this interactively here. Now we see a little bit more, and we see, okay, it doesn't take that much longer, but still, like it's maybe 100 milliseconds or 300 milliseconds as compared to 1-2 seconds. So it is kind of a difference, especially since there's actually a race condition if we don't wait for the application to be ready. And we see in case of Postgres, which is already a little bit of a better and faster image as compared to others that are out there in the wild, it does a lot of things. The application does a lot of things when the container is first started. So it creates some additional bootstrapping tables, whatever, then the server is started, and then something funny happens, and it says server is stopped, and then it starts again. So it starts, bootstraps some stuff, then restarts. And I think one can easily imagine that this could lead to a couple of race conditions if we just naively start a container and then want to interact with it. So Testcontainers has some nice logic to abstract this away, and we don't think about the container being started, but the service or the application inside the container being started. These are called wait strategies, and we will look at them in a bit of more detail later. So yeah, let's delete this stuff. All right, a little bit more about the project itself. It was first released in 2015 by this guy here, Richard North from England, but back then he was living in Japan. And it is 100% open source under MIT license. There are no like business or enterprise features whatsoever that have any paid plans or whatever, and there are also no plans to introduce those at the moment. But at the moment there's also no real paid support if you would need this. Okay, you can always hire one of us as a personal consultant, that would maybe work, but we don't have any official paid support or whatever. And over 65 releases. We have, I think, a quite healthy community, also a lot of outside contributors and other open source projects that use test containers, that contribute features and fixes, like for example Elasticsearch, they came from outside contributors, and I also think Neo4j came probably from Michael, whatever. And we also have a number of forks in other languages. So we have versions in Python, C#, in Rust, Go, JavaScript, yeah, but they are kind of, you can call them forks or you can call them re-implementations, so they don't have any shared code bases with the Testcontainers Java, which is the core project. They just try to follow the same ideas, concepts, and yeah, implement them accordingly in their own language. Alright, yeah, so Stargazers is how the stars rise. For a Java project, I think looks pretty good, over 3,000 by now, maybe now we are even closer to 4,000, haven't looked for some time. And here are some of the features. So we have what we've seen in this small code bit, support for generic Docker container. So every image that can run in a Docker container, you can run with test containers. But there are also special classes you can use that have a bit of more high-level abstractions, for example, modules for databases or features like stream processing, so things like Apache Kafka or Pulsar, and we will see them in examples in a bit more detail. For AWS, we have a local stack module. Then there is special support for Docker Compose, which many people really like when they get started with test containers, since maybe there are existing Docker Compose files for development environment or test environment, and then you can just reuse them in test containers and then maybe gradually migrate away from using Docker Compose and having this more fine granular control of this object-oriented orientation with test containers. So this is basically, okay, do I want to have imperative code like Java code to define my environment, or do I want to have something declarative like a YAML file? And I argue often something imperative is more powerful and flexible than a declarative YAML file. But yeah. Then there's support for Selenium, which people really love. This allows basically starting a container more or less headless, starting a browser more or less headless in a container, and Selenium inside, and then it gets instrumented from Java, from test containers. It also allows recording the video of what happens. So it's headless, but actually not headless, because it renders everything into a virtual frame buffer, which means we still have the rendered images as long as someone would look at them. Just they are not rendered onto our X server or into our display manager or whatever. And we have support for chaos testing with toxiproxy, so chaos engineering. You can put this toxiproxy container between other containers and then introduce anomalies such as dropped packages or dropped network connections and whatsoever. I personally haven't used this much yet, but I think this allows for some really cool scenarios and experiments also. Yes, so then a little bit more low-level other features. One is dynamic port binding or port publishing in an API that allows you to access this published port. So this is basically what happens when we would run. So let's look at it like this. If we would run, let's make it detached here again. Assume we would bind our port more or less fixed. Like we would say, okay, in the test we want to start at Postgres and it should bind to 5432 onto our localhost 5432. Then maybe this is easy, because then in the test I can just access localhost 5432. But actually in this case we already have introduced an integrated test again. So it's not really good, because if I maybe want to start parallelizing some things, or if like I map another port and another service is already using it locally, like I don't know, Skype wants to use port 80, which seems to happen or used to happen on Windows, I think, then all kind of stupid things can happen. Then I have an integrated test again. So what we much rather do is we publish the port with Docker. We use the Docker publishing port feature. Okay, and if we do this and check, then we see it gets automatically published or mapped onto an ephemeral port, which are on Linux normally, depending on your kernel settings, but normally over 32,000. And yeah, basically it guarantees you to map to a free port. And then you have an API in Testcontainers to get this map port after the container has started. And I think it's one of the most robust ways to solve this problem. But of course this means you have to have, you have to have some way to inject this configuration at runtime of your test into your system under test. So you can't have any config files that statically configure your system and your tests to access Postgres on localhost 5432, because you don't know the port yet. You only know the port after the container has started, so after the tests have been executed. Yeah, but like there are many ways to inject such variables into my system when I test, like just doing something like Constructor dependency injection, or there's special support in frameworks sometimes. So Spring nowadays supports also dynamic property sources. We will see this to make this easier. Yep. Alright, then I already mentioned we have this feature of wait strategies. So there are different kind of wait strategies available. The easiest one just checks that the exposed ports is accessible and assumes this is an indicator for the liveness of the service inside, but you can also check for the Docker health check for certain log messages, or even more complex things that you can initiate a JDBC connection or things like this. Then it works out of the box in all Docker environments. Everywhere where Docker works, this works as well. So I'm here on Linux now, but also Docker machine would work, or if you have Docker host variables configured, Docker for Mac works, Docker for Windows. So in this way we are platform independent and basically Docker distribution independent, and try to work plug and play everywhere without any configuration. And yeah, you can have test containers on Linux, on Mac, and Windows 10 on Windows 10 Pro with Windows Docker. So I'm not sure if we 100% work right now with the newly released WSL2 backend for Docker in Windows 10, which just came out in this new 2004 update. I haven't tried it out myself, and I read they still have some problems with some features from volume mounting. And I actually listened to the podcast about this update by Scott Henselman yesterday. And yeah, they are pretty involved in what they are doing there, and I would expect there are still some bugs or some quirks that not work perfectly with test containers. But we haven't tried it out yet. Alright, yes, so works, but it works on Windows, good, and works with JDK 14, like we always try to keep up with this fast JDK release cadence nowadays. Also, and yeah, I don't think we work with module paths. Last time I tried out, we didn't work because we have a split package problem, but okay, who is using module paths? Not that many people at the moment. We work in all major CI systems. We also have a lot of CI set up for test containers itself to check that we are working there. Yeah, we ourselves nowadays migrated to GitHub Actions, but before we were using Travis CI ourselves, we were using GitLab CI. Azure DevOps pipelines we started to use to do our CI builds for our Windows build, basically. Yep. And Jenkins, of course, but yeah, often people ask us, they have problems with their Jenkins or whatever, test containers not working. They say, oh, it works locally, but it doesn't work on my Jenkins. then we ask, okay, how is your Jenkins set up? How has your Jenkins access to Docker? And then they don't know. So you have to know how your CI is set up, and then then it should normally work. But if your CI does some weird stuff already, doesn't give you access to a Docker socket and those kind of things, then it often doesn't work. Yeah. So you need Docker in this environment and access to Docker, to the Docker daemon. Some of our users, companies that use us, projects that use us, I'm pretty happy about, so we are pretty happy about this strong user base, and also some big and cool open source projects. Some of the more famous ones here may be Neo4j and Spring. So Spring Data Team uses test containers internally extensively, also Spring Security. JetBrains use it for a couple of things. Oh, someone says Bitbucket, Bamboo. No. I meant Bitbucket. So this is Bitbucket Pipelines, which is the cloud CI from Atlassian. Bamboo would probably work if your Bamboo has access to a Docker daemon. Yeah. With Bitbucket pipelines, there were some problems actually, since they have a setup where the builds run on a shared host. You couldn't run a privileged containers, which Testcontainers needs to do at a certain point. So you have to deactivate some features, but then it works, and it's totally okay to deactivate these features because those Bitbucket pipelines are ephemeral after all, so they get thrown away. Yes. Alright, okay, now we come to some other things, like integration into test frameworks. Here we see JUnit 4 integration, but before I go deeper, I want to have an emphasis on the fact that these integrations are totally optional, so you can use it in a very vanilla way, like we saw before. Just use the API directly. If it's fine for you, okay. But you can also use those test framework integrations. In case of this class rule, it would mean it automatically gets started for the test class and then stopped after the test class, the container. Or you can have rule, then it would be for the rule. Sebastian asking about TeamCity. Yes, it will work in TeamCity, but depending on how your builders are set up. So your builders that execute the build need access to a Docker daemon, either locally or by something like Docker machine. All right, then here we have the Spock extension. Okay. The same idea basically. You annotate a class with Testcontainers, and then all fields that are containers in your test class get managed by Testcontainers automatically, start and stop meaning. And then for JUnit 5, JUnit Jupyter looks similar to the Spock one. You annotate the class with the Jupyter extension, Testcontainers, and then you annotate fields, container fields that should be managed by the extension. And this also works for nested tests and so on. Yep. Okay, so, and now comes the time for some demos. And I had this talk yesterday in a company. Oh, IntelliJ expires. Oh my god. In a company, and there I had the problem. We did a Jitsi call, and every time when I executed the tests, the connection to Jitsi would fail. I think because Docker, when removing the containers, like maybe reconfigures IP tables or something, and then I lost connection to the Jitsi. So I hope this doesn't happen today. Let's see. All right. So, all right, here we are. Okay, so we have a, let's look at the build Gradle maybe. So the way how to get started with test containers, just add the Maven dependency and you're good to go. So here I'm in Gradle, so I'm adding it in Gradle or in Maven, it doesn't matter, it's of course the same. And I'm adding it here with a platform dependency from Gradle, which basically means Maven BOM, so bill of materials. But you could do it also directly. So I just have it like this because then I can omit the version names of all the test containers modules here. I'm using a Postgres and the Kafka module, and then I of course have core as a transitive dependency. But instead of having this platform bomb, I could also just say, okay, 1.14.0 here, and then it's the same. So, all right. So you don't have to do more. That's all, and then you're good to go. We look at an easy example application here. Super easy, nothing framework stuff involved. So we have a book class that is kind of an entity or a DTO. It just has two fields, two string fields, name and author. And we want to save these books into a relational database by using this book repository class. And the book repository class does the interactions just using JDBC and using plain Java SQL connection class here and normal SQL statements. Okay, and we have a couple of methods here like saving books, counting number of books, searching books by author. But this code here is not the interesting point. We want to focus on the tests. In addition, we have here a second class that should be used to send out notifications from the application, like special offers. Yeah, super cool. So actually all it does, it sends a string, a message onto a Kafka topic. So this should send events on a Kafka topic. And this we also want to integration test. All right, let's look at the actual test. Here. So in this case, I'm using the JUnit Jupyter extension. So we see it annotated with Testcontainers, and here I have a container field, and here I'm using a specialized container. It's already is PostgreSQL container. So then I don't have to specify an image and tags, and it will use a default tag. We can actually look which would be the default tag just by going inside. Okay, we see here some constants. It would use PostgreSQL, Postgres. Yeah, and default tag is 9612. And yeah, then we use Flyway to set up the initial database schema, which is of course not very big since we just have this one table for books. Still, I just wanted to show the pattern. You could maybe do something like this. And then here we actually see what I mean with injecting this dynamic URLs, or the URLs that can be resolved after the container has been started and the port has been dynamically mapped. We inject those into our system under test. Our system under test in this case is just a book repository object. And so super easy way to inject it is using constructor dependency injection, thus putting the URL in the constructor. So this sounds fancy here, constructor dependency injection, but that's all what it means. Like put this URL in a constructor, or you could set it using a setter or something. But of course, many of us are working with big frameworks and big libraries, something like Hibernate, whatever, Spring Data. There you maybe don't have control over your own objects, which is also maybe something we should think about. It's a bit stupid that we don't have control over our classes and objects sometimes. But whatever. In this case, you just have to know what features your framework gives you to do this dynamic injection. And Spring supports it very well nowadays. In case of Java EE, when I used it last year, it was a bit more involved to get it in there. Not that nice. So, but also possible. And now we have a couple of tests here, like, okay, empty repository is empty, saving one book, saving a couple of books and searching them. Yeah. And I just run it, and I hope everything goes and I don't lose the connection. Yep. So it starts. We see here some log outputs already, starting containers. Yeah. Takes a couple of seconds for every test now. Alright, looks good. And if I'm still connected now, if I'm still connected after the containers are gone now, then I'm pretty confident that the connection is actually robust. Because yesterday with Jitsi it always lost the connection after the containers got removed. All right, so we see tests worked fine, but it was a little bit slow maybe, so 4 seconds for each test method is a little bit slow. I would agree with this, but we have to keep in mind we are having a new database instance, a new database container for each test method. So of course, although Docker makes it cheaper, it still is a little bit expensive. Since we saw all the stuff that the Postgres also has to do when it starts up, we get all this overhead now. So we probably want to reduce this overhead and make our integration tests faster. And what we did now, having a new database instance for every test, is of course very nice for test pollution, because I don't have to care about test pollution in this integration component anymore. But at the same time, it's expensive, so we have to pay a high price for this. And much easier is to try to solve this on a logical instead of infrastructure layer. Just meaning, okay, let's reuse this container instance. And we can just do this by making it static here. This makes the extension work as if it would be a class rule in JUnit 4. And then we just say, okay, before each test, let's just do a flyway clean and then the migrate, okay, to just start with a clean database state every time. And we can remember, okay, here it took 15 seconds, which was a bit too much for us. And now we do it again. And what takes the most time is kind of connecting to the Gradle daemon actually. And now it's much faster already, like 500 milliseconds. And I'm not 100% sure if we can trust these reported values here by JUnit or by IntelliJ, but still, we already saw it was much faster, especially after the initial bootstrapping starting of the containers, things became rapidly faster. And this is just something to keep in mind, a better approach, not just because it's easy now with test containers to start a new container for every test. This doesn't mean we should do it, because we have to pay a price. We still have to pay a price. We have to pay a price in time. And we want to have a fast feedback cycle. And if we have so many containers that get started and restarted all the time, the price is too high. Not acceptable anymore. And then you have a test suite that runs many minutes, and that's not enjoyable. You should try better, for a better approach. And it's possible with test containers, as we have seen here. I will show later another example where you even just start the container once for the whole test suite, even faster then. All right, maybe something else we can show while I run the test. I will do a watch Docker PS. Okay, and now we see, we saw a container was there, and at a certain point it goes away, and then we have this real container here. And it lingers around a bit, and at a certain time it also goes away. So we see test containers manages automatically the cleanup of all those resources, like the containers get removed when they're not needed anymore. Same would be for volumes or images or whatever. And we saw this small real container, and this is a sidecar container that gets started by test containers, and it's responsible for cleaning up the resources. And we do this outside of the JVM process, because then we can also clean up resources when the JVM crashes or gets killed or whatever. And that's very useful for CI environments, because if you would cancel a build and maybe kill the JVM by canceling the build, then you could not clean up those resources. But if you have this outside process that gets launched as a Docker container, and there's just a tiny Go binary inside, then this can still clean up. And it works by the JVM test container sending a heartbeat to this Ryuk container, and once the JVM exits, Ryuk will also clean up all the things. So this also means, on the other hand, that implicitly the lifetime of the containers started and created by test containers is bound to the lifetime of the JVM. Something to keep in mind. And maybe a limitation of test containers in this regard. So, because test containers started out with this testing mindset, but we could imagine just using this API as an object-oriented abstraction for Docker, but it will not really work since you bound now the lifecycle to the JVM. So just something to keep in mind. All right, we saw the test for JDBC, and let's check this special offer notifier test, and it works very similar. Now we have another special container, Kafka container. Same approach actually, same usage with the Testcontainers extension here. And then this Kafka container gives us a special method, get bootstrap servers. We maybe can look into the implementation here to see what it does. So it does the following. It just renders directly a URL string we can then use in our application to connect to this container with our Kafka driver, Kafka producer in this case. And it's mostly a concatenation of the container IP address and then the port, the map port, dynamically mapped port. Container IP address in this case, though, would mean the IP address that this container may be reached on. Not necessarily the local machine. So it is kind of the IP address under which the map port is reachable, not the IP address of the container. If you have the local Docker daemon, it resolves to localhost. But if you would have something like Docker machine, it would be another IP. And by having this kind of dynamically coded, it works in all environments. So it's a good way to have this dynamic approach here and not have this hard-coded URLs or whatever. Okay, so yes, I will run it. And this Kafka container, like, it contains Kafka, it also contains a zookeeper, it manages everything for you, kind of abstracts it away for you. And yeah, test is done. So this was just sending a message and then checking that the message was received on the topic. Yep. And yes, 8 seconds. So one can say, okay, 8 seconds is a little bit of time, but then one can also say, okay, 8 seconds for starting up a Kafka with a zookeeper is pretty cool. And yeah. So that's it for this part. And we go on. So I'm checking any questions about this so far. If you have any questions, just write in the chat. I sometimes try to look over and also try to answer them. So I would be happy to answer questions if they appear during the presentation, so to say. All right. Okay, then let's come to some news. So we just released Testcontainers 1.14. I think 1.14.1 now even, so we're a bit more up to date now. And we had a couple of features and changes there. One of the bigger changes was updating to Docker Java 3.2, and there were some deprecations involved, so users should check them when they were using Docker Java classes from that were exposed by Testcontainers. Yeah, some things here. Then we got support for R2DBC, so this reactive approach of JDBC URLs. This is maybe something I should highlight in the way that I didn't show the JDBC support yet, special JDBC support. So you can just check in the Testcontainers docs here. If we go into features, no, modules, database, JDBC support, and here we see R2DBC support. So we see this. And these are special JDBC URLs you can use that will then use a special Testcontainers JDBC driver proxy that will lead to a behavior that once a connection to this JDBC URL is initiated, container is started automatically. There's a very different approach to what we've seen, where we have this programmatic way of defining the containers. In this case, you have a declarative way, so to say, or some bit of auto-configuration magic. You can just statically put this JDBC URL in your config, like maybe in your test application properties in case of Spring Boot, and then you will automatically get those containers. It works just like an H2 in memory JDBC URL would work maybe. So I think it's pretty cool, and we have it for all those major databases, and you can also have it in this daemon mode. So this mode means it will keep the connection, it will keep the container alive as long as there is a connection to the database, JDBC connection open. So if you have a pool, it will also be open. Or you can have this daemon mode, then you bind it to the life cycle of the JVM. And we have now the same feature for R2DBC. So the question by Bastian, is the container started on another machine or locally? So it is started where the Docker daemon is running. So it depends on where your Docker daemon is running. Yeah. So meaning it would be started there where also the container would be started in case of just doing the Docker run, Docker container run, whatever. If your daemon is remotely, it would be remote, but most people probably have a local Docker daemon, I think. Yep, and here we have the same approach for R2DBC, so this reactive JDBC URLs kind of. Yep, this we got in 1.14. Better support for Couchbase, and this is also cool. So now the JUnit Jupyter integration is now supporting the test lifecycle aware interface, which means that we will see later a feature about automatic video recording for the browser WebDriver containers. So this now works for the JUnit Jupyter integration in the sense that you can, for example, configure to only record failed test executions. Then you get a video file for each failed Selenium test, so to say. That's cool. And better support for Docker Compose. So Conny Pflaume is asking if we can watch this again later. I don't know if the JUGH can just save the recording and publish it, then yes. So from my side, I'm fine with it. But since I don't really have control over the YouTube, I can't comment on this. All right, then something else I just wanted to mention, because it's so cool, we just added recently to Testcontainers, is that we have now a Gradle task that auto-generates our GitHub action jobs, or our CI pipeline config, so to say. And we have really a couple of modules nowadays. So Testcontainers has this core module, but then each special container, like a database, like a MySQL, Postgres, whatever, they have their own modules in which they're implemented. And having so our CI became not slow but very big. So we have a lot of integration tests we are running, because most of the things Testcontainers does has to be also tested with an integration test. And it became a bit like hard to also manually craft those CI jobs so that we can parallelize a lot. So we have now this job that for every module automatically generates jobs. So you don't have to keep in mind when you add a module to also add a CI pipeline for this or whatever. And yeah, then it looks like this, and I think it's pretty cool. So we get all this many highly parallel CI pipeline GitHub actions now, and super cool for me. And it's also a cool way to think about it, having dynamic creation of this CI pipeline files. Yeah, so we create a test matrix as part of as a Gradle task. Yeah, this is also something very nice you can do with Gradle. You just have a lot of power in Gradle. So maybe you could do something like this with Maven, but then you would need to write your own Maven plugin, I assume. And here you just do a Gradle task, you write some groovy code, and yeah, it's pretty cool, I think. Yep. Another cool thing you can see here is that it will only create those tasks if the state is not up to date. So this is kind of using already this Gradle caching or incremental build feature to see, okay, which stuff did actually change in this commit. So it knows then automatically for which modules to create CI jobs, thanks to Gradle. So actually pretty mind-blowing cool stuff if you look deeper into this. This is very nice in the new Spring 5.25, and therefore also in the newest Spring Boot we got support for dynamic property sources. And one of the reasons why they added this to Spring is to make it easier to use test containers from within Spring Boot tests. And now you can very easily have this method that is annotated with dynamic property source, and here you can add, like in this registry, you can add those dynamic properties, yes, like in URLs or ports or whatever, and this will then get basically executed after the containers have started. So this solves this problem of finding the sweet spot in the life cycle of your test framework to where the containers are started, but my Spring context is not fully started yet. Yeah, very easy. Before it was also possible, but a bit more, not really hacky, but verbose to do. Yep. All right. So now we want to look at the Docker Compose support. And we will look at an example application. Old example application from Docker, has been released by Docker some years ago on the Dockercon. It's their voting application. And the cool thing what we want to do is now we want to black box test this, do a black box UI test actually from this whole system, which consists of many different services, many microservices maybe, so to say. And now also a cool fact is that these are all implemented in different programming languages. So now we're using Testcontainers Java, to test non-Java services that are available as Docker containers. And I think this is a cool approach. For me at least, this is a cool approach because I'm so comfortable writing tests in Java. And yeah, let's look at what this does. So root new terminal. Let's go here. So I'm just starting this. Okay, I'll go into the browser. On localhost 5000 running. Okay, this is the voting app, and maybe we look quickly how it's structured. So we have two different front ends, voting and result front end. Then we have a Redis persistence layer and a Postgres persistence layer, and we have this worker threads that moves the votes from the Redis into the Postgres. Okay, we vote here. Yeah. Alright, voted, and then we check the result. Good. So everything working as expected, I think. Good, I can stop again, and now let's check how we want to test this. So yeah, demo. We already started the demo kind of. So I have another project here, example voting app. Okay, so now we use a Docker Compose file, basically the same I used. I could have used the same I used, but there we had these port mappings, and actually we don't need and we don't want those port mappings. So in this, the port mappings are removed. And now we have a test, and we do a test with Spock and JUGH, just for fun, because I like it. So we have now a Groovy file here and a Spock test. And here we see first the Docker Compose container. Very simple, very similar, actually the same interface than the other containers. But here we specify a file, a Docker Compose file. And then we say with exposed services, this would be the services we want to interact with. So where it would then do the dynamic port binding. And in addition, this will as a default configure wait strategies for those services with exposed ports. So it will wait for those services to be accessible, and then this is kind of the wait strategy here implicitly. But you could also configure it by hand and configure different wait strategies for the different services. And then I'm having another special test container here, the browser WebDriver container. And this is what I already mentioned before. This will contain a browser, will run in this kind of headless mode where it renders everything in a virtual frame buffer. We say here, okay, it should be one for Chrome. It could be Chrome or Firefox. Of course, Internet Explorer is not supported. We are having Docker containers here. And then we have this recording mode. Now, so recording mode, VNC recording mode, record all. And in this case, test containers will launch also a sidecar container that has a VNC recorder inside. It will do a VNC connection to this Selenium container and then do a video recording of what is happening in the container, in the browser. So pretty cool, I think. Now what we also do is a bit more involved. I will not go into detail, but basically after starting, so I'm now starting these things by hand. I'm not using those extensions. I'm starting it by hand to have a little bit more control. So I want to first start compose by hand, then I'm calling here some method I wrote to find out the network ID of the vote service, of the Docker network in this case. With Docker Compose, of course, Docker Compose is in control about creating and managing the networks and not test containers. So we have to now find out, okay, what is this network? If we would not use Docker Compose, we could also use something like network. Actually, so I'm not. So we have a method to create a network. Yeah, new network. Okay. New. Not sure why it doesn't work right now. So doesn't matter. But there are methods in test containers to create Docker networks, and then you can say on the container with network. What? Okay, then there's something wrong with my Groovy here probably. Let me just check if it would go in the normal Java file here. A second. So here I'm back in my old one. So yeah, I don't know what is wrong there with my Groovy file, whatever. But in normally you have this with network method, and you can do something like network dot. Okay, right now I'm missing the syntax, to be honest. But there is an API to create networks in test containers. Okay, we go back to our acceptance test. And here we have it, at least there. There we have new network. Okay. But here I create an anonymous network. Whatever. Let's not dive into the details of the network stuff right now. We have documentation about this if someone wants to know. Here it says features, networking and communication with networks. So advanced networking here, network.new network. That was the method I wanted to call. I don't know why it didn't work now. And you can do this kind of thing. Okay. In this case, I'm not doing this. I'm not creating a new network with test containers. Instead, I'm getting the ID of the network that has been created by Compose. And now I'm putting my Chrome container, the Selenium container, onto the same network. And why am I doing this? Because then I can leverage Docker DNS, and then I can indeed statically configure the URLs, because then I have just the service names as kind of the DNS of the Docker. That's very cool. And here now we look at the tests. These are JEP tests. JEP is a Groovy DSL for Selenium. And here we say, okay, browser, first go to the vote website. I have here a couple of sleeps. Of course, you should never have sleeps in a Selenium test, but I was lazy to write it. And in addition, if I don't have the sleeps, the test is over too fast. So, and then you don't see anything in the video recording. So go to the vote website, check that we have this text there visible, these buttons, go on the result website, check that everything is 50-50, go again to the vote website, click on the first button, go on the result website, check that everything is 100% now. And I will just execute this here now. Okay, yes, Gradle starting, some stuff is happening. Yep, so we see here creating services, creating containers, we see our VNC recorder, we see already the tests being successful. Alright, all tests passed. And now if we check this build directory test results, as you can see I've run this, yeah, now here a video, which one is it? This, yeah, video file appeared, so let's check this. Okay, and here we see a video recording of what was happening in the container. Yep, and I think it's pretty cool. And you can also do things if you want, like have a breakpoint somewhere. And here you see me. Oh, we can actually try it. Let me check if I have a VNC client. Yes, let's try it out. So I want to show you now that you can also. Let's do it here. Okay. Now we do debug. Alright, so you can also attach into this browser container using VNC, which is kind of convenient sometimes. And then do interactive stuff, like do whatever you want. So yeah, I'm here, and if you check here, chrome.vnc address, yep, yeah, we get this here. I use just not calendar. Wow, everything leaked. Too much private data leaked. Remino, I wanted to start. Yes, okay. VNC, okay. Then probably the has to be actually like this more. Yeah. Password secret. Okay. And now I'm here in the container. And what was the website? I think just vote. No, HTTP vote, yeah. Cool. Okay. And I can do whatever I want. Like, no, I don't want to open the settings. I wanted more tools. Yeah, debug around here, do whatever I want. Yeah. Pretty convenient sometimes. Okay, I stop it and then I also lose connection. Everything gets cleaned up. Okay. So I still have it running. Yeah, we see, okay, everything goes away. Everything nicely cleans up. I killed the JVM now actually by stopping the debug process, or killing the debug process, but then the Reu cleans everything up. Cool. All right, let's go a little bit further. Yeah, this is something I just have in here as a reference. It's a blog post from my colleague Sergey, where he explains how you can also use test containers as a replacement for Docker Compose for the local development environment. And this is nice. This is basically for a Spring Boot application, just having a second Spring Boot application class, for example, in your tests. And then this class would also, using test containers, start the environment and then start the Spring Boot application. Then you don't need a Docker Compose. And then you also don't need to be sure that the developer executes Docker Compose up before running the application to test something out. It will all work out of the box. I think the approach is a cool idea. It's a great idea, I think. Yeah. Okay, then, if you're already running your CI inside a container with the stuff we are looking here at your work as well. And to make a long story short, let's just say yes, it will, but it depends on your strategy to execute Docker from inside a Docker container. There are mainly two roads you can go by. One is using Docker in Docker. This would have a Docker daemon running inside your container, and GitLab CI works like this, but this will lead to a lot of problems. You will basically not really have a Docker image layer cache, and this would make the builds pretty slow. But yeah, sometimes you maybe have to do it if you're using a shared CI environment or whatever. But don't have the idea to oh, maybe I can cache those image layers as Docker volume between those different build containers or whatever, because then this kind of thing happens. So Docker daemon is not made for concurrently writing in its own image layer cache, and then you get corruption there and everything breaks. Terrible. The approach I personally prefer is Docker wormhole pattern, and Roland Hus called it like this the first time in a blog post, as far as I know, Docker wormhole pattern. And here you mount the Docker socket into your build container. Yeah, so we have below here is our host, we have a Docker engine running here, we have the build container that gets spawned for the build, we mount the Docker socket in there, and then Docker clients or Docker clients such as Testcontainers would interact with the daemon over the socket, this mounted socket, and then the containers that get spawned are sibling containers instead of child containers. Works very well. The only thing you have to be aware of that volume, host mounts for files, would now be mounted from the host, not from inside the build container. This is maybe a bit confusing if you're new to Docker or you're not really sure how your CI is set up. So yes, it works, and it works when Docker works inside this Docker container, but here you have to know how your CI is set up and how you want to set up your CI. And very often, if people are struggling with this is not a problem with test containers, it is just the problem that people don't really know how they have set up their CI server and their CI system. So make sure Docker is accessible from inside the containers, and test container will work. Good. A little bit of outlook in the future and some common pitfalls there might be when using test containers maybe. This one I will jump over this. This is like the self-typing we use for allowing fluent setters in our builder-like API, whatever. This is a bit more of an internal implementation detail and only important if you're writing your own test containers modules. So let's jump over this topic. This one I find personally also more important. And this is the case that, so I like TDD a lot, test-driven development. And I also think you can basically do TDD with integration tests. Real TDD, like hardliners would maybe say, no, you can never do it. But I think you can do it if the integration tests are fast enough. And very often I want to do this TDD approach with integration tests, like, for example, when I have SQL stuff. And it's totally fine and super cool to have business logic in SQL statements. Sometimes this is the best place to have it for many different reasons. In this case, if we would use test containers, we would have a new container for every run. Like every time we make a change in our TDD cycle, we get a new container there, and things become slow. Even with containers, they are slow. And waiting a couple of seconds, that's not the experience you want to have. So this container startup adds simply overhead. Overhead we can't at the moment circumvent. And at the same time, we really want test containers to have ephemeral containers, especially when you run in the CI. You want to have this the security of knowing that you have this fresh environment you're running in. So like test pollution and integrated tests, we don't want to have them over test runs. And we have this nice tweet by Jens from the Spring Data team, where he said, okay, yes, when he is doing TDD cycles against the MS SQL server or testing, experimenting with the code, it's better to not use test containers, instead have a locally running instance, maybe locally started by Docker, because else it becomes a bit slow and bothersome. And yes, I generally agree with this. So this is a feature that is lacking for test containers. But, then a thing maybe many people don't know yet, we have a new, here's suck. We have a new feature, alpha, super alpha, incubating feature, so to say, reusable containers that would survive the lifetime of the JVM process, so to say. And yeah, it's actually in there now for quite some time. So nearly 1 year we started with this, but sometimes it takes some time in open source projects to come to a real final results. In this case, it's a case in this time. So here you see some things that you have to do to use reusable containers. So it's an opt-in feature at the moment. You have to set this test containers property, reuse enable, and then you also have to set it on the containers itself. So let's check how it looks. First, let's check these properties. So here I have set it here, test containers reuse enable. So it's an opt-in. It's an opt-in for this alpha feature, but it's also an opt-in for the workstation, so to say. Because on the CI you don't want this feature to be enabled. At the same time, you don't want to have code changes between CI and the workstation, your development workstation. So I have it there enabled, and let's check now. I have another test. Reusable test, okay, and this looks like similar to the one we had before now, and the only thing that changed is that I say here with reuse true. And so in the case that with reuse is true is set and this property is set to enable it, then test containers will keep these containers alive and reuse them for future test runs. So we executed. I think it will be actually not that much faster than the one where we had the static. No, it's quite fast, but we have the highest overhead is now starting the build or communicating with the Gradle daemon for whatever reason. So yeah, okay, in total 366. Yeah, it will probably be the same because of the way like this is reported and that we have the main overhead when connecting to the Gradle daemon, and the way this is reported there are some accumulated numbers here actually, but if we check here we see that the container stays up, and if we do watch, okay, I'll just run again. Yeah, so we see the sidecar container gets still started, but the old container just keeps on running. And yeah, there's kind of a grace period configured for it so that it gets killed if it hasn't been used, taken out of cache for half an hour, yeah, and then it gets killed at a certain point. But this feature actually not that implemented yet. So yeah. But that is the idea, the direction where this is going to. And to check if it can reuse a container, we are using the let's just Docker.ts. We are using the the structure, the JSON structure of the container, the JSON description of the container. Like this, okay. Basically, this a hash version of this container definition as our cache key to give you only the container you really want in this case. Yeah, so this is very hard actually because caching is hard, but so far this seems to work pretty well. All right. Yeah. So yes, Sebastian. Yes, they stay alive after the test is done. Yes, as I said. There is this grace period. If they haven't been taken out of cache for half an hour or so, then they should get deleted. That is the ultimate idea. This is also good for debugging. So with the old usage pattern, the container would also, if the test would fail, it would get thrown away else, and then you maybe can't inspect like the state of the container afterwards. So that might be a nice feature in this kind of circumstances. Or else just have a breakpoint somewhere before the tests end, and then you can also look into the container. All right, more future. So at one point we want to go into the direction of Testcontainers 2.0, where we will have some changes for the API, maybe also for the DSL for creating and defining containers. Okay, I have this here, complete Podman support, but actually this is not the highest priority for us personally at the moment. But we're in touch with some Red Hat people, and also Red Hat people are very supportive. They also try to get Podman working. So actually what we say as test containers, we say we don't want to support Podman. We say if Podman is a drop-in replacement for Docker, then it should just work. And yeah, I think we are is a valid standpoint we are having here, but one could argue about this. So Podman is generally communicated as a drop-in replacement for Docker. So why doesn't it work then out of the box with test containers? Because it's actually not a drop-in replacement. There are some differences in features and also in some behaviors. And first of all, the classic Podman is just a drop-in replacement for the Docker CLI. But test containers and many other tools interacting with Docker are not using the CLI. They're using the REST API that the Docker daemon exposes, the Docker socket. But there are some efforts from Podman to replicate this API with a Podman server. Yeah, but it still behaves different than Docker because it doesn't work with test containers yet. Some problems also with the volume mounting, and I think the networks work totally different. So yeah, let's see. I would like to say test container support is perfectly because I know some companies can only use Podman probably for whatever business enterprise reasons. And also we see, of course, Red Hat pushing Podman quite a lot with new Fedora version, with new CentOS and RHEL version, where it's very hard. Christian is installing WSL2, yes. So I wait for WSL2 until it's available in general availability. So I don't want to opt into the installer preview, but then I also want to try out how it works with test containers. Yeah, I think there will be some quirks. Yeah, okay, back to the Podman stuff. So whatever Red Hat, I think also on current Fedora, Docker is broken out of the box. You have to configure some things to make Docker work again. So I don't know, whatever the reasons, the Docker support is not that great in Red Hat world right now. So yeah, therefore many people maybe fall back to Podman, using Podman. Maybe that is a strategy. No, I don't want to make too much assumptions here. Too many unfair assumptions. For this reason, I understand that test containers users are asking for Podman support. It will come, I think, at one point, if Red Hat will have made a drop-in replacement, really. Okay, then from our point of view, we are thinking about in the Testcontainers 2.0 version to have a core library extracted out of test containers that would be called container core. And this is just the object-oriented abstraction of Docker, which many people like and you want to use, and removing all those test stuff and also removing the cleanup stuff, because if you have this object-oriented abstraction, you don't want to have this cleanup. This cleanup is more related to the testing world. And yeah, this is something I hope we could provide at a certain point in future, trying to align the other languages and the existing forks. This is a cool link to a blog post by Oleg from Oracle, who used test containers in GraalVM in this polyglot mode, and then interacted with test containers Java from Node.js. Very cool. So very cool. This GraalVM polyglot stuff, mind blowing cool for me. All right. No, I want to go. Yeah. Okay, yes, so this is the current architecture of Testcontainers 1. And as you can see, we have this core that depends on JUnit 4. There's a problem, historic legacy problem, so to say. And we want to solve this by having a container core library in the future that doesn't have any relations to any test libraries, and then we have those different modules that implement it. Yes, and then in the far future, in theory we could provide support for Windows container on Windows. However, we can only support this once Windows would support running the container daemon in hybrid mode, meaning supporting Linux containers and Windows containers at the same time. This is a necessary requirement since we have Linux container-based sidecar containers we use, and we don't want to rewrite them all as Windows containers. Then it would work directly out of the box. So I tried it out once with deactivating all our sidecar containers. Then Windows containers on Windows directly work because the API is the same as the Docker API. Support for orchestrators. So Docker Swarm support. We are using Docker Java as a library, and Docker Java, I think, now already supports Docker Swarm. So this could work in theory. However, one might argue maybe Docker Swarm will die out in the near future, or maybe not. I'm not sure. Let's see. Dockercon is today. Let's see what they will announce. Oh, I think because of my long talk, we're all missing the Dockercon keynote. Sad. Maybe they will announce some cool stuff. Maybe they will announce they got bought by Microsoft. I think something like this. Yeah, cool. Okay, the other elephant in the room is Kubernetes support. People ask this very often. We can't provide this at the moment. We don't have the time or the resources or the expertise to build this in. Someone else would need to come and help, but I think it's not as easy as people assume it would be. Yeah. In the future with Testcontainers 2, we could potentially see support for other container engines or container-like engines. Yeah, we have here Podman support, although Podman support ideally wouldn't need a special implementation. But something like Firecracker, maybe those Amazon Firecracker VMs, this stuff would be cool. And I think it would be nice to have this engine driver implementation extracted so we can provide users with different choices. Then last but not least, I always dreamed about that IDEs get a better support for building and executing everything and testing everything inside a container, and I thought this will never come, or yeah, I thought it will never come. But actually, after the recent announcement on GitHub Satellite and those remote development environments in GitHub, which are basically the Visual Studio Code remote development environments, I think we are pretty close now. And this is awesome, because if our build and test environment already runs more or less transparently inside a container, it means we can leverage from inside the test process Docker networking. So then we can just attach us into the same Docker network or whatever and use Docker DNS, and then we can use static URLs again, and that's actually cool. So then we don't have to do this dynamic port binding stuff anymore. We can leverage Docker DNS. I like this very much. I hope we get a feature like this in IntelliJ, and then I would also be able to use it, because I will not switch to Visual Studio Code just because this is cooler. But yeah, I think in theory JetBrains could implement such a thing, because they basically have this feature in PyCharm, but they don't have it in JetBrains, in IntelliJ. Yeah. Or it could be maybe a cool Maven or Gradle plugin that executes everything transparently in a container, and since IntelliJ delegates to Gradle, it would also work then transparently. Yeah, I'm just dreaming here. Cool, here I have links. I will share the slides and the links afterwards. Yeah, you can get the source code examples I did. You can clone the repositories, you can execute them, and they should work out of the box. Also this example with the browser WebDriver. Many people like this and think it's cool that you can just clone execute it. And yes, I'm done. Not 2 hours, but nearly, so it was a long time. My first streaming experience. It was okay, yes, it was fun. Of course, it's much more fun to see the people also and have real Java user group experience, but I tried my best, and we all have to somehow live with the current situation. And I was still am very happy that I could give this talk here now at the Java user group Hessen. And yeah, I hope I will come back in the future in persona and maybe talk about blockchains or whatever, or again about test container stuff. And thank you very much. If there are any questions, of course, ask them. I get them with some delay, I think, here. But yeah, I idle around a bit, and else we can all go and switch to the Dockercon live stream. So I definitely will check out some stuff. On Saturday, we can all check the launch of SpaceX, the rescheduled launch, and it's just 50% chance that they don't launch because of bad weather. So very good. Yes, I will get a drink. Speaking a lot, drink necessary. I will get some dinner. Yeah, but streaming cool. I like this OBS studio experience. So maybe in the future I can do like the other streaming stars we have, some Twitch streaming where I do live test containers, pull request reviews or something like this. Let's see. Yeah. All right. Thank you very much. Thank you very much. Thanks to everyone. Yes. Great that you were there. Those two Christians there. Hi. Great that you were there. All right, and I think now, okay, yes, here I can create some cool recursive streaming here. If there are no real questions anymore, I will just stop the stream. I can just switch to here, and I don't know. Not sure if